This question tests understanding of the types of business analytics, specifically the distinction between descriptive, diagnostic, predictive, and prescriptive analytics. The scenario states that an analysis of historical hotel occupancy data concluded that the decline in food and beverage revenue was mostly due to low hotel occupancy. The key phrase is due mostly to, which indicates that the analysis is identifying the cause of an observed outcome. Diagnostic analytics focuses on explaining why something happened by examining relationships among historical data. Students should remember the four common categories of analytics. Descriptive answers what happened, diagnostic answers why it happened, predictive estimates what is likely to happen, and prescriptive recommends what should be done. Recognizing these differences is essential for interpreting business intelligence reports and supporting managerial decision-making. A. Descriptive analytics, incorrect. Descriptive analytics summarizes historical information and reports what happened but does not explain the underlying cause. B. Diagnostic analytics, correct. Diagnostic analytics investigates historical data to determine why an event occurred, such as identifying low occupancy as the primary reason for declining food and beverage revenue. C. Predictive analytics, incorrect. Predictive analytics uses historical data to forecast future outcomes rather than explain past events. D. Prescriptive analytics, incorrect. Prescriptive analytics recommends actions or decisions to optimize future performance based on analytical results. Correct answer, B. The analysis is an example of diagnostic analytics because it examines historical data to determine the cause of a business outcome, helping management understand why revenue declined and supporting better future decisions. This question tests understanding of the different types of data analytics used in business intelligence and financial planning. The CFO wants to use a large amount of available data to prepare a 5-year forecast, indicating that the objective is to estimate future business performance. The key phrase is 5-year forecast, which emphasizes predicting future outcomes rather than describing or explaining past events. Students should remember the 4 major categories of analytics. Descriptive analytics summarizes what happened, diagnostic analytics explains why it happened, predictive analytics forecasts what is likely to happen, and prescriptive analytics recommends the best actions to achieve desired outcomes. Since forecasting relies on historical data, statistical models, and machine learning techniques to estimate future trends, the appropriate analytical approach is predictive analytics. A. Descriptive, incorrect. Descriptive analytics summarizes historical information and reports past performance but does not forecast future results. B. Diagnostic, incorrect. Diagnostic analytics investigates historical data to explain why certain events occurred rather than predicting future outcomes. C. Predictive, correct. Predictive analytics uses historical data, statistical models, and advanced algorithms to forecast future events, making it well suited for preparing a 5-year financial forecast. D. Prescriptive, incorrect. Prescriptive analytics recommends optimal actions after predictions have been made but is not primarily used to generate forecasts. Correct answer, C. The CFO should use predictive analytics because it analyzes historical and current data to estimate future performance, supporting long-term financial planning and strategic decision-making. This question tests knowledge of correlation coefficients used in regression and statistical analysis. A correlation coefficient measures the strength and direction of the linear relationship between an independent variable and a dependent variable. Its value always ranges from -1 to +1. A value close to +1 indicates a strong positive relationship, while a value close to -1 indicates a strong negative relationship. A value near 0 suggests little or no linear relationship. The question asks for the strongest relationship, meaning students should compare the absolute values of the valid coefficients rather than their signs. They should also recognize that any value outside the interval -1 to +1 is impossible for a correlation coefficient and therefore cannot be considered. A. 1.05, incorrect. A correlation coefficient cannot exceed +1 or be less than -1. Therefore, 1.05 is invalid and cannot represent any relationship. B. 0.72, incorrect. This indicates a moderately strong positive relationship, but it is not the strongest among the valid choices. C. -0.04, incorrect. This value is very close to 0, indicating almost no linear relationship between the variables. D. -0.88, correct. The absolute value is 0.88, which is the largest valid coefficient listed. It represents a strong negative linear relationship, meaning the dependent variable tends to decrease as the independent variable increases. Correct answer, D. A correlation coefficient of -0.88 represents the strongest relationship among the valid options because its magnitude is closest to 1, indicating a strong linear association. This question tests the application of simple linear regression, which models the relationship between an independent variable, x, and a dependent variable, y, using the equation y equals a plus bx, where a is the y-intercept and b is the slope of the regression line. The problem states that the slope is 0.8, meaning that for every additional toaster sold, expected toaster oven sales increase by 0.8 units. It also states that when 10,500 toasters are forecast to be sold, the expected sales of toaster ovens are 13,128 units. The information about February sales and the minimum monthly sales is not required for calculating the intercept and serves as distractor information. Students should substitute the known values into the regression equation and solve for a, the y-intercept. Using the regression equation, y equals a plus bx. Substitute the given values. 13,128 equals a plus 0.8, 10,500. A equals 13,128, 8,400 is equal to 4,728. The calculated y-intercept is 4,728. Since this exact value is not listed, the closest and intended answer is 4,700, which also matches the statement that the department store will sell at least 4,700 toaster ovens per month. A. 4,700 correct. It is the intended approximation of the calculated intercept. B. 8,400 incorrect. This is the value of 0.8 times 10,500, not the intercept. C. 9,360 incorrect. This value is unrelated to the regression calculation. D. 13,128 incorrect. This is the predicted sales level, not the y-intercept. Correct answer, A. 4,700. This question tests understanding of logistic regression, a widely used statistical technique in business analytics, finance, and machine learning. Logistic regression is designed for situations where the dependent variable is categorical, typically having two possible outcomes, such as approve or reject a loan, fraud or non-fraud, success or failure, or purchase or no purchase. Unlike linear regression, which predicts a continuous numerical value, logistic regression estimates the probability that an observation belongs to a particular category. It uses one or more independent variables to predict a binary outcome and is commonly applied in credit risk assessment, customer churn prediction, and medical diagnosis. Students should distinguish logistic regression from clustering methods and linear regression models that predict continuous variables. A statistical method used to describe relationships between a set of independent variables and a continuous outcome. Incorrect. This defines linear regression, which predicts continuous numerical values rather than categories. B. A machine learning algorithm that clusters similar data points together. Incorrect. This describes clustering algorithms, such as k-means clustering, not logistic regression. C. A statistical method used for predicting one of two outcomes for an event. Correct. Logistic regression predicts the probability of a binary outcome, making it suitable for classification problems with two possible results. D. A machine learning algorithm that finds the best fitting straight line through data points. Incorrect. This describes linear regression, not logistic regression. Correct answer, C. Logistic regression is a statistical method used to predict one of two possible outcomes, making it a fundamental tool for binary classification problems in business and finance.